again, I'm sorry. Alright, I wanted to help you guys with some clarifications on how to do lab 2-3. It's really, really easy, okay? So you're going to set your lab like this. I think I'm going to use a color pen you can probably see better. So, you're going to choose only one ramp angle, okay? Don't make it too steep, alright? You'll have a timer right up here and a timer down there, okay? And you're going to need to know, right here, the distance where you put these two things, okay? Alright. What you want to do is you're going to find the time at A, and you're going to find the time at B, and then you're going to find the time between A and B. Okay, these three things are going to be necessary so that you can be able to find the acceleration rate. Now, what is acceleration? You guys know that acceleration is the change in speed or the change in velocity over the change in time. Okay? So, the formula for acceleration is A is equal to delta V over T. Alright? You know that the little cart, the little wing on it, it's out here like this. Here's the wheels. Got this little tiny wing right here. This wing is 5 centimeters wide. From there to there. 5.0 centimeters. It's exactly 5 centimeters. You could say to the 10th of a centimeter probably. Okay? Alright, so if you find the time at A, this thing has gone through there during that time. Okay? So you can go like this. The velocity at A would be equal to, we can call it 5 centimeters. I'm not sure if the book wants you to do it in centimeters or meters. I always like meters, but if they say centimeters, that's okay. Divided by the time at A. Okay? So that would give you the velocity here. So you'll know the velocity here because it's just 5 divided by whatever that time is. The velocity down here, the velocity at B, is just going to be 5 divided by whatever that time is. Don't you think that velocity is going to be higher than this velocity? Well, obviously, because it accelerated. Okay? So then all you have to do is, you know that acceleration is the change in velocity over the change in time. So you go like this. The velocity at B, this one is the bigger one, minus the velocity at A, that's the velocity up here, divided by the time. And that's going to be the time from A to B. See the change in time from here to there. And that's all you have to do to be able to find the acceleration. It's really, really not very hard. Okay? Now, you're going to do 2 trials because science should always have more than one trial because of experimental error. The 2 trials should be pretty close. If they're not close, then that means you made a mistake somewhere and try it again. Okay? Then after this, you're going to take your data and you're going to graph this data on the little lab sheet that Miss McGee has for you. Okay? So take that lab sheet, take that data and graph it. Okay? When you graph it, they incorrectly say you're supposed to graph speed on the y-axis. You know that that's not right. It's really velocity. So you put velocity, and if they're allowing you to use centimeters, go ahead and say centimeters per second. Then here is time down here. Now this is the time from A to B. Okay? So this is where it was at A, and this is what the velocity is at B. Okay? Alright, now this would be in seconds. So your graph is going to look like something like this probably. It's not going to start at 0. Okay? And then, what you need to do is you need to find the slope. You can draw a triangle if you want, and it's the rise over the run. So it's the change in y over the change in x. Everybody in your class knows how to find slope. Okay? If you want to help each other, go ahead. Alright? So the slope is equal to the acceleration. Because, see, it is the change in the velocity, that's what y is, over the change in time. That's what x is. Okay? So I hope you do a really good job with this. Just, answer all the questions thoughtfully. And if you have a little bit extra time, you can have a bit of a study hall. But do a really good job answering these questions and be thoughtful, because I'm going to grade them carefully. Okay? Sorry I'm gone. I'll hopefully be back tomorrow. Bye-bye.